Okay, welcome back, everyone. Hopefully the rest will get back also because the quizzes will shut down on them. So let's go over the quiz. Let me share my desktop and talk about how to answer these quiz questions. Okay, so here's the quiz. And question number 1 is consider the parametric curve x of t equals t minus t to the fourth, y of t equals t squared minus t cubed. And the question is, find the equation of the tangent line to this curve when t equals 2. So to do that, to find the equation of the tangent line, what two things do you have to know to find the equation of a line? What's the two major thing?
dy and dx.
Okay, you need to find dy dx. I'm calling that one thing, though. What's the other thing you have to find?
The point of intersection.
Not quite intersection, just a point.
Yeah, just the point where you plug in 2 to the original equation.
Yeah. So this is just a tangent line. You just need a point on the line. So let's do dy dx first. So remember that dy over dx is equal to dy over dt over dx over dt. Okay, and I want to mention, if you want to make it fancy looking, you can, but it's not necessary. Hopefully you can read what I've written, and hopefully you wrote something like that too. And what is that equal to? Okay, there's no trick questions here. dy dt is supposed to be pretty easy. What is that? I know it's early morning, but hopefully you can all tell me what dy dt is.
2t plus 3t squared.
Yeah, 2t plus 3t squared. Over, and then dx dt is?
1 minus 4t cubed.
Yeah, 1 minus 4t cubed. Any questions on that? Okay, now we want the equation of the tangent line. So we need the slope, and that's the whole point of what we just did. But we have more to do to find the slope. And what is the last step to find the slope?
2t plus tt squared divided by 1 minus 4t cubed, and then you plug in 2.
No, I like what Alexi said. You're going way too long. Plug in 2. Just plug in 2 right away. You don't need to simplify first. So much easier to just plug in. Do you agree? And I'm going to do this. I'll do it in my head and say it out when I do it in my head. And however you do it is the way you do it. But you plug in 2, you get 2 times 2 is 4. 2 squared is 4 times 3 is 12. 12 plus 2 is 14. And then 2 cubed is 8. 8 times 4 is 32. 1 minus 32 is negative 31. Okay. And that I'm going to write just for more familiarity stuff. That's equal to what you're used to calling m, the slope. Any questions on this? No tricks. Just find dy dt over dx dt and plug in.
That's is that not like 12 plus 4?
Yeah, that's what I was going to ask too.
Oh, did I make a mistake? Let's see. Oh yeah, that was a 4. Sorry. 12 plus 4 is 16. Thanks. Okay, then what we do is we need to find a point. How do you find a point? Very easy.
Plug in t to those first equations.
Plug in 2. Plug in 2 for the parametric curve. If you plug in 2, you get 2 minus 2 to the fourth. 2 to the fourth is 16. 2 minus 16 is negative 14. And then if you plug in 2 for the y equation, you get 2 squared plus 2 cubed. That's 4 plus 8, and that's 12. Any questions on that? Okay, now we got to remember our very basic algebra, which is
y minus y naught equals mx minus x naught.
Yeah, y minus, I like to call it y1, but you can call it y naught, however you want. So y minus y1, y minus 12 equals m, which is 16 over negative 31. Let me write it as negative 16 over 31. It's just a little prettier. Times x minus negative 14. So x plus 14. Am I finished?
No, you have to distribute.
Wait, one more guess.
Nope, just the calculus, Larry.
I'm finished. Yeah, I'm finished. The answer is yes, I'm finished. That's it. Okay, we did the calculus. Okay, so I don't require that you do algebra and simplification. Do we have an equation? Yes, that's all that matters. And this is the tangent line of the curve. And in the real world, actually, sometimes this is better than solving for y, and doing simplifying, because it kind of tells a story pretty well. So it really depends what you're interested in. And since this doesn't talk about what you're interested in, but leave it the easiest way possible. Any questions on number 1? Okay, again, not meant to be a trick question. All these are pretty standard, but you have to remember what we did 2 days ago. Okay, let's look at question 2. Now we have a parametric curve. X of t equals to t plus cosine t, y of t equals t minus e to the t. Find d squared over d squared y over dx squared. Okay, so to find d squared y over dx squared, what do you first have to find?
Y over dx.
Yeah, we find dy over dx. So first thing is, let's find dy over dx. And again, from question 1, basically, that's dy over dt over dx over dt. So dy over dt, hopefully you remember how to take derivatives. Derivative of 1 minus e to the t is, t minus e to the t is 1 minus e to the t. I kind of gave it away. And then the derivative of t plus cosine t is 1 minus sine of t. Any questions on that? Okay, what's the next step?
Take the derivative of that using the quotient rule.
Yeah, we need to take the derivative of that with respect to t. And we're going to use the quotient rule. And I warned you 2 days ago that quotient rule usually happens on these because you're taking a derivative of a quotient. That usually uses the quotient rule. So now what we need to do is find d over dt of dy over dt. And that we use the quotient rule. So the quotient rule says low, which is 1 minus sine of t, times d high, which is negative e to the t, and then minus high, which is 1 minus e to the t, times d low, and the derivative of 1 minus sine t is negative cosine t. And then it says square the bottom and away you go, right? So 1 minus sine t squared. Any questions? Are we finished?
We are not.
Yeah, we're not finished. Okay. And I told you the number one thing people forget, and I'm seeing the chat box, it's still happening, no matter how much I warn you. You got to divide by dx dt. Okay. Okay. So you can divide by dx dt. So let's do that. And the nice thing is what I can do is the following. I can write d squared y over dx squared is equal to, and what I can do is I can just take this guy, copy it, and pasting. Sometimes it's easier to do on paper, but in this case it's not because I can copy paste. And dividing by dx dt is the same thing as sticking in another one, a dx dt in the denominator. So I'm going to go divided by 1 minus sine t squared times t plus cosine t. Am I done? Oh, not t plus cosine. Sorry, 1 minus sine t was dx dt.
Doesn't that just make 1 minus sine t cubed?
If you want.
Okay. Because if I wrote it that way, is that the same thing?
Let's see, 1 minus sine t. Yeah,
Yeah. Okay.
yeah, that's the same.
Thank you.
But I use copy and paste. To me, that's easier. Okay, and that's it. Again, if you simplify, don't take off points if you simplify correctly. But if you simplify incorrectly, you could lose points. So you decide whether you want to take the chance. The only time you really want to simplify is if you have more work to do. So if I asked you, which would have been like if I were in a really bad mood when I wrote this, if I asked you to find the third derivative, then you'd probably want to simplify. Okay,
That's
but I have to be
evil.
huh?
That's evil. More
Yeah,
work.
I wasn't in a really bad mood. Yeah, I wasn't in a really bad mood. But if I was in a really bad mood, I could have done that, but I wasn't. Okay, but the second derivative, I felt very comfortable since that's what we talked about. Okay, any questions at all on question 2? Okay, let's go to question 3. Okay, consider the parametrically defined curve. X of t is t plus t cubed. Y of t is 1 plus t squared. Find the area of the region below this curve, above the x-axis, and within t between 0 and 3. I don't know why it bold-faced it, but that wasn't on purpose. Okay, so now you have to remember how do we find the area of a curve?
Integral of a to b gt f prime of t dt.
Right. So that's going to
So
be.
my quiz actually says 0 to 1.
Oh, really?
Yeah.
Did everyone else have 0 to 1?
Yes.
Okay. Do you know what happens with Canvas sometimes? I apologize. Is when I save it, sometimes it only saves on my screen and not everyone else's. But here it is. It's saved for me. So I apologize. I'll do 0 to 1. It really doesn't really matter too much. But we'll do 0 to 1. Sound good? Yeah. So weird. Canvas is weird sometimes when it comes to saving. Because I did hit, obviously hit save because there it is. But I guess you didn't see it. So sorry about that. Okay, so make that 0 to 1. I promise I didn't do this on purpose. Okay, so again, I'm just going to write int sub 0 super 1, just so you remember. So that means the integral from 0 to 1. Again, if you want to make it pretty, you can. And you can go to the equation editor and do all that stuff, but it's not necessary. Okay, and then what do I write?
You write what y of t equals and x prime of t.
Yeah, so y of t is
1 plus
1
t
plus
squared.
t squared.
And then the x prime is 1 plus 3x squared.
Plus 3t squared.
Oh, 3t squared. Oops.
And dt. Any questions on that? Okay, we actually need to find this. So how do you integrate this? Do I have to use do I use product
Foiled
rule?
it out, so I had all the individual things and then integrated
Definitely.
that.
Definitely. Foil it out. Don't try and use integration by parts or anything weird like that. None of that's going to work. Just keep it simple. Int sub 0 super 1 of 1. Let's write in parentheses 1 plus, and now we're going to have a t squared plus 3t squared is 4t squared. And then plus 3t to the fourth. So yeah, there's calculus, dt, but nothing too evil, right? And then how do you integrate a polynomial? Hopefully you all remember. If not, I need to talk to Bruce because that was absolutely required to know how to integrate a polynomial. The integral of 1 is t. And then the integral of 4t squared is you're all supposed to remember
8t.
we're not taking derivative, we're taking
Oh, wait.
yeah, 4t cubed over 3. And then the integral of 3t to the fourth is
3t to the fifth divided by 5.
Over 5. We don't need a plus c because we're going from 0 to 1. And the nice thing is plugging in is not that bad. And if you plug in 1, you get 1 plus 4/3 and plus 3/5. What happens if you plug in 0, by the way? Yeah, you just get 0. So we're done. I mean, if you want to simplify this, you can, but you don't need to. Some number of 15ths. Any questions at all on question 3? Any questions? Okay, question 4. Consider the parametrically defined curve x of t equals t e to the 2t, and y of t is t plus sine t. T goes from 0 to 4. Set the integral that gives the length of the curve. All right, so for this integral, we're going to have an integral, obviously, or I wouldn't have said set up the integral, from 0 to 4. That's not supposed to be hard. And then how does the formula work?
It's a square root of x prime t squared plus y prime t squared.
Exactly. So it's the square root of x prime of t squared plus y prime of t squared. So square root, I'll use SQRT for that. And then x prime, how do we find x prime? What rules do we have to use?
The product rule.
Product and the chain
Oh,
rule.
yes. Yeah,
Chain
rule.
rule. So the root of the first is 1, so you get e to the 2t. Guess I'll go 2t. And then plus, actually I need a parenthesis around that. Actually, not got enough parentheses, I'm fine. And then plus t times the derivative of the 2t, which is 2e to the 2t. So 2t e to the 2t. All squared. And then plus, and now the derivative of t plus sine of t, quantity squared. So that's 1 plus cosine of t, all squared, dt. By the way, what would happen if you tried to integrate this by hand? Any thoughts?
It would look like a disaster.
Yeah, you would give up. You would give up. Any guess on what would happen if you say stuck it in Symbolab or, you know, or Maple or one of those programs? Any guess?
I don't know if it would be able to find it.
Yeah, it would say cannot evaluate this integral. It'll just give you I can't do this. So not only couldn't you do it, but neither could anything do it. Okay. Do you think you'll ever be able to do something like this? The answer
I
is
would love to think that the answer is yes, but since you said that like the computer can't, I'm
the
not
answer.
sure how
The
we would be
answer
able
is
to.
yes in June. And you'll be crying as you're doing it. Just a note. Although I wouldn't give you something this miserable because it's that miserable. But even things like, hopefully Bruce told you e to the x squared dx, that can't you can't integrate that until June. So it can be integrated, but not in what's called closed form. So that's why the computer does things in closed form, and we'll learn about what that means later. But I want to give you the heads up that we actually are going to do, we're going to realize we're going to have this big sledgehammer that does everything at a cost, at a very steep cost. But for now, this just said, set up the integral, so I'm done.
Our quiz, it's worth 2 points. But on your
Yeah, it's
screen,
supposed to be,
showing
it was
one.
supposed to be worth 2. So I did make some changes. I don't know why this thing saved weirdly. So some kind of weird saving. So it'll work. Your quiz, some reason the save on this one didn't work. So yours, I'm glad yours worked 2 because that saved it right. Some reason it didn't save on mine is the thing. Okay, any questions on the quiz? Because that's everything. All right, let's go to new material. So let me switch screens, go there. Okay, so are there any questions about anything? And you could ask questions about anything, no guarantee I'll answer, but math I should be able to answer.
Question.
Yeah, what is it?
It's number 13, I think.
Remember, everyone has a different number 13. So you have to be able to read it to me.
Can I type it? I just copy it.
You stick it in the chat box, I mean? Sure. Okay. Was yesterday's quiz supposed to be in the assignments category? I'll have to look at that. So if it was in the wrong category, I apologize. But I'll take a look at it after class. Make sure the quizzes are all in the right place. Sometimes things get weird with Canvas. Yeah, so if it was in the wrong place, I apologize. Should be, all the quizzes should be in the same place. Okay, find the area of the surface obtained by rotating the given curve about the x-axis, round your answer to the nearest whole number. All right, and we have x equals t squared. So let me type this out. So x equals t squared. Y equals 2t. And 0 less than or equal to, I'll just write less than t, it doesn't matter. Actually, I think it does equal. Does it? Nope. Less than t, less than 9. Okay, and we want to find the area, and we're going to revolve it around the x-axis. All right, so you want to find the area of the surface. Okay, so do you remember that the area, this is last quarter. Hopefully you all remember what all the details of last quarter. And you remember the formula for the area of a surface revolved around the x-axis? You remember? You integrate.
So
Wait, don't
2
you-
pi r, or the integral of 2 pi r, and then the length, arc length formula.
Yeah, so it's the integral of 2 pi r times the length. Okay.
R would be the axis that is not the one you're rotating it around.
Yeah, so in this case, it's the y-axis. It's the y-coordinate. I like to say coordinate instead of axis. Right? Because the radius is the distance from the x-axis to what you're rotating, and that's a y distance since it's a vertical distance. Does that make sense so far? Okay, so let's do that. And I'm going to go insert equation. So we're going to have an integral. Is it that one? Yeah. Integral from 0 to 9. And then it's going to be 2 pi. And usually you pop 2 pi outside. So 2 pi. Again, it's up to you whether you want to put it inside or outside, but most people put it outside. And then again, the radius is the y coordinate or the y distance, and y is 2t. And then the length is the length formula that we had in the question we just did, which was, if you remember, the square root of the x function derivatives squared, and that's going to be 4t squared. Stop me if you're not following any of the pieces, and then plus take the derivative of the y coordinate, that's 2, so that's going to be plus 4, and then dt. Did I lose you at all, Phony? Any questions on that?
No, thank you.
Okay, and by the way, this is actually a pretty easy integral. You don't actually need some fancy calculator or something. How do you do this integral? What's the technique?
Just plug in 9 minus 0.
You definitely don't need trig
you-
sub. Trig sub is, it would work. It would be obnoxious and horrible. U sub is much easier. You just you can't plug in 9 and 0 yet. You got to integrate first. But do a little simple U sub. U equal 4t squared plus 4. Du is 8t dt. And we already have a 4t. So that means we're going to have a half pi. There's pi. And then we're going to have an integral. And again, if u is 4t squared, if u is 0, if t is 0, u is 0. If t is 9, then it's 4t squared plus 4. So that's going to be 4 if t is 0. And then if t is 9, 9 squared is 81. 81 times 4 is 324 plus 4 is 328. Bit messy. And that's the square root and actually let's write it as a u to the 1/2 du, and I'll let you do the rest. The rest is just kind of busy work. Any questions on that? Any questions on that idea?
Just a comment. That problem took me like an hour.
Oh, really? It took me about 3 minutes, I think.
Well,
I mean,
you
it would
know.
take me another 3 minutes, maybe 2 minutes to work it out. And that's all by hand.
Yeah.
You definitely would need a calculator to do.
Well, maybe an hour is an
root of eight.
exaggeration. More like 40 minutes.
Okay. Now, if you tried to do by hand, 328 to the 3 power, that could take you an hour. But hopefully you didn't do that. Use a calculator for that, or computer calculator. Did I do it an easier way? If it took you
You
40
did it
minutes,
pretty much the exact same way that I did it, but
and that took 40 minutes, really?
yeah. Well, all the other problems took a lot less time.
Mm-hmm. Yeah.
This
I
one
still
just,
see-
sometimes I just some things just aren't readily apparent.
It just took a while. Yeah, it took a while to think about it, I guess, because the writing isn't that much. Again, I skipped some steps. I didn't write u equals 4t squared plus 4, du equals 8t dt. That would take another minute, so. But it shouldn't take too long. Okay, let's see. Erez has a question. And that is find the points on the curve. And I'm going to do this one and then we'll call it because we need to do new material too. Find the points on the curve. X equals t squared minus 18t plus 9. Y equals t squared plus t2 plus 10t minus 3 that have vertical and horizontal tangent lines. All right, so the good news is it could take you 40 minutes, but it won't take me 40 minutes. That's a guarantee. So here's the question. We want to find the vertical and horizontal tangent lines on this curve. All right, so just remember, let's just write this down. And that is dy over dx is equal to dy over dt over dx over dt. Again, that's the big equation that happened 2 days ago. And if you have a horizontal tangent line, what do you know about the derivative?
It's 0.
It's 0. And if you have a vertical tangent line, what do you know about the derivative?
Also 0.
Not 0.
But undefined.
Yeah, undefined, but in particular, it's more than just undefined. It's an asymptote. Okay, so vertical tangent lines have asymptotes for their derivative, which is different than undefined. Because undefined could be, say, a 0 over 0 or square root of -1. And a square root of -1 is not a vertical tangent line. It's just undefined. Do you see the difference? So that's something to note. So let's start with the horizontal. So let's do horizontal first. So the horizontal means you get 0. Well, if you have a fraction and you get 0, what do you know?
The numerator is 0.
Exactly. The numerator is 0 and the numerator is dy dt. And dy dt is 2t plus 10. And hopefully you can do this in your head too and say t is -5. Does that totally make sense, or did I lose you somewhere? Okay, and let's see, what was it asked? Find the points on the curve. So that would mean then you got to plug in -5. That's just busy work. Okay, so I'm just going to say x comma y. I'll let you plug in. Is that okay? You just plug in -5 in for the t here, -5 in for the t here, use a calculator, and it'll give you numbers. And how about vertical? What do we set? Also easy.
dx dt to 0.
Yeah, we set dx dt to 0. dx dt is 2t minus 18 equals 0. So t is equal to 9. And let me just remind you, the last step, is it okay if I don't do the last step? You plug in 9 in for t and you get x and y. It's just messy arithmetic, but nothing more than that. Did I make it easier than you thought? That's how these usually are, right? Yeah, and that's it. We got a horizontal, we got a vertical tangent lines. Okay, or the points at which they happen. You do have to plug in, but plugging in is not hard. All right, so now I got an interesting question for you. You got to think back to when you were in maybe 6th grade, okay, which is a long time for all of you. I don't think we have any 7th graders in this class. And you learned how to plot points. So you learned that if you're given a point in the plane, you learn the coordinates of that point. Do you remember that? Okay, and that was maybe 6th grade, maybe 7th, but probably 6th grade. I learned it in 7th, but that's because when my generation, we did algebra later and that kind of stuff. But your generation does it a little earlier. Okay, so things happen. So if you have a point, maybe I'll even do a drawing. I'm going to try it. Never does drawings well. So just a warning, it may crash on me. So if I do a drawing, all right, give me that drawing. There we go. And then we look at a point. You learned when you were much younger how to think about that point and talk about its coordinates. Okay, and I purposely put this on a grid so we have actually units. How do you, so what are the coordinates of this point? Again, you learn this in, when you're a child, middle school. I know you had hormones going through you in a big way, but hopefully you still remember. So,
Right over run.
that'd be a slope, right? Just on coordinates. There's no line here. It's just a point.
Oh, XY.
Right. And here's the tough question that your teacher probably never told you. Why? Why do you call the coordinates of this point by saying, let's go over here on the x-axis, see how far you go, and then you go up on the y-axis and see how far you go? Why is it that we do that? And my guess is your 6th grade teacher never told you, but maybe you could figure it out. Okay. Yeah, it's a tough question. Okay. I don't expect any of you to have an answer, a true answer to it, because there is no answer. I mean, I guess the answer would be do it because you were told to do it when you're in 6th grade. Sound right? And so pretty much in 6th grade, what you were told is that you found the coordinates of the point by seeing how far you have to walk along the x-axis and how far you have to walk up the y-axis. And that'll give you coordinates, and if you give those two numbers, that uniquely defines a point. Do you agree? But what if you were told in 6th grade that you should go up and then you go right? Would that be legal? If our whole society changed and we did it that way, would we have mathematical contradictions if we all learned it that way in our life? It'd be fine, right? Or what if they said the x-axis, positive numbers are on the left and negative numbers are on the right? Would that be okay? Sure. All right, so all of those work. But I'm going to talk about another way of finding coordinates of the point. Okay, now I'm going too far. Okay, well, I'm going to go even farther. Okay, but the farther what I'm going to do now is a little different. It's going to be a little more sophisticated, but it's just as good as walking to the right and then walking up. And that is start at the origin. And instead of walking to the right and then going up, let's just go direct. Why should we do it in pieces? Where should we walk? If you have an origin, you have a point, how should you go?
In a straight line because it's faster.
Yeah, just go to the point. Don't you think that makes sense? And see how far you have to walk to get to the point. I don't know if you ever thought about that, but doesn't that make more sense than this weird going right and then going up? Just walk to the point and see how far you went. Any questions on that? All right, but you have to do more than that, because the problem is if we had a point, say, over here that was the same distance, you'd get the same number. So one number is not enough to talk about where a point is. But you do want to talk about how far you are from the center. So what you want to do is you say, well, let's call the first coordinate how far you are from the center. And let's call the second coordinate the angle from the x-axis. So now I'm going to draw more diagrams like so. And then I'm going to draw this guy here like so. Any questions on that? And we're going to define the point instead of let's see how far right and how much up you go. We're going to see how far you have to go to get to the point and what angle you had to walk from the x-axis to get to that point. Any questions on that idea? We'll get to the distance formula, but we don't even need, we're just looking at that distance. We're going to like walk and see how tired we are at the end. You'll know how far you went. Because I know how, I could walk 5 miles and I'll feel it. And I knew I walked 5 miles. Okay, so the point is that we can talk about coordinates of a point in many different ways. Okay, the way you've learned all your life since 6th grade was go right and then go up. But now we're going to change that. Now we're going to say, let's see how far it is away from the origin and what angle it is from there. Any questions on that? Where have you seen something like that in real life, living in Tahoe? But more advanced actually than what I just did. And we'll get to that later. Snowboarding, skiing, curvy roads. I'm talking about coordinates here. Curvy roads aren't. I'm talking about coordinates, how you define coordinates of where you are. Maybe none of you are hikers like I am. Yeah, you go GPS, so you go north, you go east, but there's one more thing. Northeast isn't really enough. You also need to talk about elevation. If you don't live in Tahoe, then I'm going to give you an excuse. But in Tahoe, we care about elevation because we're in a mountain. So typically you want to talk about how far you are from sea level, or you can go a little more advanced and say center of the earth if you wanted. They're related. And then also what your latitude and longitude are. Okay. And because in Tahoe, elevation matters in a big way because we have it in a big way. Whereas if you live in Florida, most people wouldn't even understand it, right? But in Tahoe, we get it because that's kind of what we're doing here. We're talking about how high you have to go up and then what angle you're going to do. But when you're talking about in 3 dimensions, we'll get into that later in this quarter. And that'll be something called spherical coordinates. Okay, whereas this is going to be called polar coordinates. Any questions so far? Okay, so now that I have that, I'm going to, I think if I save it, it may die and then we have to start again. So sorry about that. See what happens. Oh no, it worked. It's like half the time it dies on me. It didn't this time. Okay, so there's our picture, and we can talk about the coordinates, and you kind of want to look at the point and you want to say how far you went. Well, if you don't know the angle, then there are a lot of points that are all that distance, and all the points that are that distance are on what kind of shape? All the points that are, say, 3 away, yeah, they're all in a circle. And the distance from the center to the edge is called what? Radius. And what's the first letter of radius? I hope you all know that one. R. So what we're going to do is we're going to have a new coordinate system, and it's called polar coordinates. And the variables we're going to use for polar coordinates are R for the radius or the distance from the center to the point, and then the angle. And what's the common letter used for angle? That's really hard to type in the chat box. Yeah, theta. Unfortunately, I can do it as an equation. Whoa. Let's try again. There we go. So polar coordinates are going to be of the form r comma theta, where r is the distance from the origin, which is 0, 0, by the way, to the point. And theta is the angle from the ray that goes, so easy to like show you and hard to type. Okay, there's a lot to type about it, but that's okay. So that goes from the origin to the point and the x-axis, positive x-axis. Any questions at all on the definition of polar coordinates? Any questions on that? All right, in the real world, when do you think polar coordinates are going to be better to use than our good old-fashioned, what we call rectangular coordinates? Any thoughts? Airplanes, maybe, maybe not. Depends on what you're doing in an airplane. Again, first thing with airplanes, usually you don't use either of these because airplanes you have to deal with in 3 dimensions, and this is 2 dimensions. Does that make sense? So airplanes, we're going to use like spherical coordinates possibly, but not polar. And spherical we haven't learned yet, but just trust me that we'll get there. So we're talking 2 dimensions. When do you think polar will be better than rectangular? It's kind of a real world engineering kind of problems. Any thoughts? Across countries. I'm not sure what you mean by that. I'm not sure the engineering behind it.
If you're trying to, it's because we use imperial, but Europe uses metric.
That's a whole different thing. Yeah, that's totally different. That's like, do we use our stupid system with inches and stuff or meters? That has nothing to do with polar or rectangular, actually, because the radius can be measured in either. So that's a whole different issue. All right, maybe I'll mention a couple, and then you'll probably believe me. In physics, we have that thing called gravity. And gravity is related to how far something is from the center. So example, if you're looking at the solar system, which really lies in a plane, basically a plane, then if you're going to be looking at the solar system and trying to do the physics of the solar system, then it makes a lot more sense to use polar coordinates because you want to talk about how far from the sun you are. There is no like natural X and Y coordinates in the solar system, but there's definitely a natural center, a natural distance from the center. Does that make sense? And gravity works with a distance issue. Any questions on that? Okay, another one is electrical engineering. Do we have any EE majors, electrical engineering types? And if you want to do that, usually I get 1 or 2. Yeah, circuit analysis. Yeah, so circuits. And that's similarly if you have magnetism, electricity and magnetism, then things tend to be attracted based on how far you are from that center, right? So if you have a magnetic field, then it's how far you are from the magnetic field that matters, not left, right, up, down. Yeah, exactly. Magnitude angle. That is polar coordinates. Okay, so that's just another way of saying polar coordinates. Okay, so there are a lot of different reasons, uses for polar coordinates. When you don't want to use polar coordinates is when the x and y axes are really important and that's all you care about. Okay, when you're talking about east, west, north, south, and that's what you care about, polar coordinates are a bad idea. Okay, but if you have something that's like attracted and depending how far you are from the center, that matters. Any questions on polar coordinates as a definition and the purpose? Okay, so here's a picture that's more advanced. I just stole this from the book, which I'm allowed to do. And we have, again, two different ways of talking about the coordinates of a point. One is your x comma y, and the other is r comma theta. The good news is that you rarely have to say which one you're doing. If I say, 2 comma pi over 3, what do you think I'm talking about, polar or rectangular? If I said,
Polar?
yeah, because it's almost always obvious, because usually if you're having an angle, that angle is going to be in pi over somethings. So it'll be obvious it's polar. Okay, but sometimes you have to talk about it. You have to actually state that it's polar because it may not be obvious, especially if you've like put in a calculator and you've rounded and stuff, and 3.7 comma 5.6. So that's hard to know. Okay, so just a note, this is the picture, and what we want to do is we want to go from one to another. So if we know r and theta, how do we get x and y? Any questions on that idea? And the good news, or bad news if you hated the class, is you learned it in trig. So if I tell you what r and theta is, can you tell me what x is? How can you write x in terms of r and theta? So so I'm looking for an equation. So what is x in terms of r and theta, which you did in your trig class? So remember, this x up on top is also the x in the bottom. It's also this bottom length. So we're looking at x, we're looking at r, and we have our theta. So we have two sides of a right triangle. Notice x is the adjacent side and r is the hypotenuse. What trig relates the adjacent and the hypotenuse? Cosine. So we know that the cosine of theta is x over r, so x is r cosine theta. And similarly, what trig relates the opposite in hypotenuse to the angle? And that's going to be a sine. So we know that the sine of theta is y over r, so y is r sine theta. And then I think, if I remember right, I put it over here. I have two more to do. So then finally, we want to say, well, what if we know x and y and you want to get r? What's the relationship between x and y and r? You've learned all this stuff, so I shouldn't have to fully derive it. Yeah, you could do the Pythagorean theorem and say that x squared plus y squared is r squared. Isn't that beautiful? Okay, what if you want theta and you know x and y? Well, x is the adjacent, y is the opposite. What trig formula relates the adjacent and the opposite to an angle? That's tangent. So let me give you the punchline, which is our big theorem. And basically, I just proved it in words by talking about it and pointing to the picture. And that really is a proof, actually. Normally you have to write what I said, but this might be closed caption, so it's written. So in particular, x equals r cosine theta. Y equals, oh, you know what? That's wrong. Y equals r sine theta. X squared plus y squared is r squared. And theta is the arctangent of y over x. Okay, which is the same thing as tangent of theta is y over x. Any questions? Any questions on these big four formulas? Okay. Notice, by the way, if you want r by itself, you take a square root, but that's just messier to write, so people don't usually write it that way. But hopefully you know how to take a square root if you need to. So any questions on the theorem about polar coordinates? Okay. There is an issue with polar coordinates. So if I told you that the coordinate of a point is 3, let me do it in an equation, 3 comma 5 pi. Could you tell me where that point is? Okay, my guess is you could. You can't? Okay, if you can't, that means that you didn't understand what I just talked about. It means you start at the origin and you go out 3 and you rotate 5 pi around. Time? No, this is just points. There's no time issues. There's no animation going on. It just says rotate 5 pi and go out 3. Or go out 3 and rotate 5 pi.
Okay, well, I was thinking 3 as maybe some kind of velocity or type of magnitude, which you could display in different lengths of time, but never mind.
No, 3 is just r. So if you go back to the, the picture, it just means you go out 3 from the origin, which this could be, say, 3 away, and then you rotate 5 pi around. If you rotate 5 pi around, where am I going to end up?
That 180 or pi.
Remember 180 degrees temperature Fahrenheit? Is that what you're talking about?
No, I said pi afterwards.
Okay, yeah, 180 means temperature in this class. Okay, so it means you're going to be over here. Okay, now here's an issue. What if I started and said I have a point right here, 3 away from the origin? What are the polar coordinates for that point? Okay, actually -3 comma 0. I like that. It's probably not what you would say at first. It's true, it's -3 comma 0, but most people would say 3 comma pi. But I'm glad you brought this up, Alexi, because it's also -3 comma 0. Because if I go -3 radius, now what does -3 radius mean? And what it really means is go in the opposite direction.
The west side of the circle?
Yeah, so, well, not just west side, but it just means that you have a -3 radius, which feels weird, doesn't it? But you can actually say that. And you usually allow r to be negative. And if r is negative, then you flip across the origin. So it says that we're going to take 0 degrees, 3 out, and then flip across the origin. But here's the thing. If I gave you this point, my guess is none of you would end up writing down 3 comma 5 pi. Even though 3 comma 5 pi was what we started with, right? But none of you would probably do that. So one of the issues with polar coordinates is they're not unique. Okay? On the other hand, rectangular coordinates are unique. If I told you, what are the rectangular coordinates for this point? All of you would have the same answer no matter what. Does that make sense? Given that we had measurement systems, same measurement system. because there is a unique answer to rectangular coordinates. There is no unique answer for polar coordinates. It gets worse. What if I'm at the origin? What angle am I at? Put in the chat box what angle it is. Give me a number.
100.
In the chat box. Okay. All right. I was actually thinking pi over 12. Am I at that angle? Sure. Anything you say is correct. And that is kind of messy when it comes to coordinate systems. Is that the origin? Any angle works. So it's even worse than not being unique before. Now it's like ridiculous to even talk about an angle at the origin. There is, you can use any number you want, and that causes all kinds of issues. So be aware of the issues that polar coordinates bring up. And the biggest issue is you do not have a unique way of stating the angle. Okay? And even the radius, because the radius can be negative. Okay? Because you can do a negative radius with a flip across the, with a flip across the origin, and you'll get the same point. So there's uniqueness issues. So it's something to worry about. Okay, so the next thing is what if we have formulas? And what do the graphs look like? I'm going to just do it in thinking about it, and then we'll draw. So what about the equation theta equals pi over 4? In one word, what is that? It's a 4-letter word. If theta is pi over 4 in one word, what does it look like? Yeah, it's a line. So theta is pi over 4 is a line. So let me go back up. So that means we're going to be at an angle pi over 4, but anything on this line has an angle pi over 4. So that line is theta is pi over 4. So every line through the origin can be written theta as a constant. So in a way, lines through the origin are nicer in polar coordinates than they are in rectangular. In rectangular, you need y equals, bx. A little messier. Whereas in polar coordinates, it's just a number. Theta is a number, you're done. It's a constant. Okay, let's look at the next one. R equals 2. In one word, what is that? That's 6 letters, by the way. Yeah, that one's a circle. Because it says that you're 2 away from the origin, that's a circle. And in particular, it's a circle of radius 2. Any questions on that? Okay, how about R equals cosine theta? What is that? That one's going to be a little harder. So that one we have to think about. Let's go up here. Okay, maybe I'll draw this one because I think it's worth it. And then we'll do some of the others doing the easy way. But I think it's good to know how to draw. Okay, so I want R equals cosine theta. So in particular, if theta is 0, what's cosine of 0? 1. So that means I'm going to start at 1. I'll just call this distance 1. Sound good? And then what's going to happen is I start rotating counterclockwise. What's going to happen to cosine of theta? Any thoughts? It's going to fluctuate, but in particular, if I stay in quadrant 1, it's going to get smaller and smaller and smaller. So as I rotate, it's going to go like that until I get to pi over 2, at which cosine of pi over 2 is 0. So now I'm radius 0. Any questions on that? Then what's going to happen after I pass the pi over 2 mark? What happens to the cosine? Becomes negative, and negative means you flip it across the axis. So that means instead of quadrant 2, I'll go into quadrant 4 until I get to pi, and at pi, then I'll be cosine of pi is -1. That's going to flip to there. Okay, and then if I go into the 4th quadrant, that's still going to be negative. It's going to flip, and I'm just going to continue rotating around. Okay, now this is not a perfect graph because I just did a drawing picture, but I want you to get an idea of how you can visualize the drawing from the equation. Okay, in particular, what does this kind of look like? In a word? I'm not a great artist, so it's not exactly it because I can't draw it that well.
A circle.
What is it? It's a circle. So this one's a circle. Okay, so it's a circle. Turns out the center is not at the origin. That we can see. The center turns out to be at 1/2 on the x-axis, 0 on the y-axis. So in rectangular coordinates, 1/2, 0. And it has radius 1/2. So when you look at it, let's see if it allows it. Good. So r equals cosine theta, you may not have looked at this and said, oh, that's a circle, but it is. How can I turn r equals cosine theta and turn it into rectangular coordinates without drawing it? Well, take a look. We have cosine theta. What would we rather have instead of cosine theta? Take a look at our theorem. We'd rather have r cosine theta. Think your x was the right idea. We'd rather have r cosine theta. So in particular, I want it to be r cosine theta, so I'm going to multiply r on both sides. So r squared equals r cosine theta. And that's real common. If you just have cosine theta multiplied by r, if you just have sine theta multiplied by r, what's r squared? Hopefully you all know. What's r squared? If you don't know, here's a little memory. What's r squared? Yeah, x squared plus y squared. So that tells you x squared plus y squared is equal to, and r cosine theta was x. So there's a rectangular coordinate system way of writing it. And then if you felt like it, you can subtract x, complete the square, and you'll end up with a circle like we talked about. Any questions on this idea? I want to get into this one, r equals theta, because that's so pretty, isn't it? What do you think that looks like? What's that going to look like in one word? 6 letters. Yeah, it's going to be a spiral because you're going to start at radius 0 when you're at theta 0. And then you start rotating and get farther and farther away until you just spiral out. By the way, do spirals ever happen in the real world? Golden ratio, that can, yeah, the spiral golden ratio could happen. All kinds of places. Yeah, like everywhere. I'm not sure about everywhere, but a lot of places. I actually saw it on Lake Tahoe. I saw this beautiful, beautiful spiral in the lake. It was beautiful. Standing on the top of Friel Peak, I was able to see this beautiful spiral, and it just happens. So it happens in nature. Whenever you have water that's rotating, you'll get a spiral. Turns out the Martian ice is in a spiral on its pole. There's all kinds of spiral biological things going on. You know, shells and stuff are often spiral. So spirals happen. R equals theta is important. And good luck trying to do rectangular coordinates for that. It's just so messy. Just a note. All right. Yeah, the pine cone is spiral. There are lots of spirals. Okay. So I want to show you some others, and I'm going to do Desmos. So if you're going to use Desmos, so for example, how about R equals sine of, how about 4 theta? What do you think sine of 4 theta might look like? Before I type it. Okay, it's going to be beautiful. Isn't that pretty? Okay, where have you seen that? The hint is it's spring right now. Yeah, flowers. Okay, so you can actually do some really beautiful. Yeah, star anise is another way of seeing that you've seen it. Okay, so when you have sine of 4 theta, by the way, how many petals are in sine of 4 theta? 8. Any guess how many petals are going to be in sine of 8 theta? Cosine of 4 theta. Any guess before I type it? Okay, let's see. So if I go cosine of 4 theta, and I still have 8. What if I had cosine of 5 theta? How many petals do you think? 5. Trick question. Okay, it turns out for odd multiples, the cosine is that number. For even, it's twice that number. Okay, and I'll let you play with it and see. But you can get really pretty stuff using polar equations instead of rectangular, regular old-fashioned equations. Any questions on this? Okay, if I asked you to turn this into a rectangular equation, that meant that I'm in a really bad mood. Just let you know. This would be an evil question. Do you know how you'd have to do it? Any thoughts? You'd have to use the 5-angle formula, which I'm sure you all memorized from trig, right? It is evil. So we're not doing it. I won't make you do it. I'm not going to do all of these, but you can get the idea. I want to mention, since we have just a little time left, a little bit of symmetry. And that is, if you have the point r theta, and you want to reflect it across the x-axis, then how does it change r and theta? First, how does it change r? So if we have a point and we want to reflect it, so maybe a point over here and want to reflect it, yeah, r doesn't change at all. Does theta change? Yeah, of course. Otherwise it wouldn't. If r and theta don't change, you haven't moved the point. How does theta change? If you go from here to here, how have you changed theta? Yeah, it's negative is not quite the right word, but your idea is probably right. what you're doing is you are starting with theta and you are multiplying by -1. So theta goes to -1. Let me write it as -1 times theta. How about the origin? If you reflect across the origin, you have a couple choices. One is you can send r to -r. Or how is theta going to change if you don't want to use negative radii? Okay. Yeah, you're going to add or subtract pi. So I'm going to add. So, or theta goes to theta plus pi. How about the y-axis? If you reflect across the y-axis, then the radius doesn't change. How does theta change? So if you were to start over here and you ended up over here, how does theta change? Plus pi over 2 doesn't quite work because if you're like, so if you're over here on the x-axis, then you move over and you're still on the x-axis, adding pi over 2 would move it up here. Okay, so theta goes to pi minus theta. That one's a little harder, but if you think about it a while, you'll probably be convinced. So that's how you deal with symmetry across axes in the origin. Okay, and I want to make a quick note. When you're finding intersections of curves, you got to be very careful. So if you have r equals cosine theta and r equals sine theta, and you want to find the intersection, kind of mathematically, what do you tend to do if you have r equals something and r equals something else? What do we do to solve? Yeah, we set them equal to each other. And we can say cosine theta equals sine theta. Okay. So what that tells you is that what is theta? When are cosine and sine the same? Yeah, pi over 4. Or 3 pi over 4. So do you think I just solved the question? Let's take a look. So r equals cosine of theta and r equals sine of theta. What's the problem? Pi over 4 and 3 pi over 4 turn out to both be here. But the problem is there's another intersection point we missed. Do you all see that? And that's the origin. So you got to be very careful when you're finding intersections about just saying, well, I'm going to set them equal and I'm done. You're not done. Because notice that this point has different angle thetas for the cosine curve and the sine curve. Right? So for the cosine curve, theta is pi over 2. For the sine curve, theta is 0. So they're different thetas, but they're the same point. So beware about when you're finding intersections, don't think you're done just because you set them equal to each other, because that doesn't work. Okay, you end up missing stuff. So what you usually want to do is graph both, look at the points, and then go find them and make sure you don't miss anything. But we're out of time. So I'm going to stop the share, stop the recording.